Hello children, welcome to my channel. This is Tangents part 1, chapter number 18 of class 10. Okay, this is the last chapter of geometry for this academic session. Okay, already you have studied about circles, so this is directly related to circles. Okay, this chapter is directly related to circles. So, uh, in this chapter, all the theorems of circles will be used. Okay, but there are some extra theorems in this chapter which I am going to teach today. First, let us understand what a tangent is. Okay, suppose we have a circle. Okay, we have a circle in this plane. Now, suppose I will draw lines again in this plane. Okay, I will draw lines in this plane. Then I can get three types of lines. This is one line which doesn't have any relation with the circle. Okay, it doesn't touch the circle even. There can be another line which will intersect the circle at 2 points. 1, 2. This is A, suppose. This is B. This line is intersecting the circle at 2 points. Such a line is called secant. Okay. So when the line intersects a circle or cuts a circle, it is called secant. Then the third line, which will just touch the circle like this. This is a special line which is simply touching the circle at one point. Let the point be P. This line is called tangent. Okay, and tangent means to touch. Okay, it is simply touching the circle, as you can see. Now the point where the line is touching the circle, this point is called point of contact. Okay, this is called secant and this is called tangent. Ready? So that means at a given point on the circumference, we can draw only one tangent. If I try to draw any other tangent through the point P, then it will not remain a tangent, it will become a secant. For example, I am drawing another line through P. Okay, I will draw another line through P. Let us see if it is a tangent. Now see this line. Is this line tangent? Means is it touching the circle or it is intersecting the circle? Clearly it is intersecting the circle at 2 points. That means it is not a tangent, it is a secant. Okay, so remember, at a given point on the circumference of a circle, you can draw only one tangent. Clear? Next, theorem number 1. Theorem number 1 states that the angle between a tangent and radius through the point of contact is 90 degree. So read the theorem again. The angle between a tangent and the radius, through the point of contact is 90 degree. That means if we have a circle like this, let O be the center. Okay. Let us draw a radius. Suppose OP is the radius. Now through P we will draw one tangent. Okay. A few minutes before I told you that through a point on the circumference we can draw only one tangent. So let us draw a tangent. This is the tangent. Okay. And OP is the radius. They are touching each other at point P. Okay. Now angle between the radius and the tangent through the point of contact is 90 degree. This is 90 degree. Okay. This is 90 degree. So remember the theorem. The angle between tangent and radius is 90 degree. Next we have a corollary which is very important. Okay. Two tangents can be drawn to a circle from an exterior point. Okay. Two tangents can be drawn to a circle from an exterior point. Let me explain this. This is a circle. Suppose O is the center. We will take an exterior point P. Exterior point P. Now from this point we can draw two tangents. Remember, a few minutes before I have told, through a point on the circumference we can draw only one tangent. And through an exterior point we can draw two tangents. Remember this. But if you take any point inside the circle, suppose O. O is a point inside the circle. Don't take it as center. Imagine that it is a point inside the circle. Now through O, is it possible that we can draw tangents to the circle? It is not possible. Whatever lines you draw through the point O, they will become secants. They will not become tangents. Remember this. So through a point inside the circle, no tangent is possible. Through a point on the circumference, one tangent is possible, only one. Through a point outside the circle, means from a point outside the circle, you can draw two tangents. This is one tangent. This is another tangent. Okay. Let the points of contact be A and B. Okay, so we can draw two tangents. Then we have some important points in this corollary. Number one, the tangents are equal in length, means PA is equal to PB. Remember this. PA is equal to PB. I am not writing. Okay, the tangents are equal in length. Next point. They subtend, means the two tangents subtend equal angles at the center. Means let us join PO. Let us join PO, OB and OA. Okay, PO, AO, BO. Now according to this, means as per this corollary, these two tangents will subtend equal angles at the center. Means this angle is equal to this angle. So angle AOP is equal to angle BO. So remember, the tangents subtend equal angles at the center. The third point is the two tangents tangents are equally inclined to the line joining the point and the center. Point means exterior point. Okay, again I am repeating. The two tangents are equally inclined to the line joining the exterior point and the center. Means this angle is equal to this angle. Okay, so angle OPA is equal to angle OPB. Okay, that means the tangents are equally inclined to the line joining the exterior point and the center. So these are the 3 points which you have to remember. Okay, we have one more theorem. Theorem number 2. When two circles touch each other externally or internally. Okay, when two circles touch each other externally or internally, their central line passes through the point of contact. Okay, so remember this. When two circles touch each other, it may be externally, it may be internally, doesn't matter, but the central line will pass through the point of contact. Okay, I am drawing a diagram to explain this. This is one circle, this is another circle. Okay, they are touching each other, you can see externally. This is external face. Let the centers be A and P. Let the point of contact be P. Okay, if you join AB, it will pass through the point of contact. Means AB is the central line. Okay, joining the center. Central line means the line joining the centers. Okay, so the central line AB is clearly passing through the point of contact P. Okay, so remember this. This is external case, internal case also same thing. Let the center be A. This is not an accurate circle. Okay, no problem. This is the point of contact P. This is the center of the smaller circle B. In this case, the circles are touching each other internally. If you join AB, it will be the central line, the line joining the centers. Now, if you produce this central line, it will pass through the point of contact P. Okay, so remember this theorem. When two circles touch each other externally or internally, the central line passes through the point of contact. Clear? Then the last theorem of this chapter. The remaining theorems are out of syllabus for this academic session due to this pandemic. Otherwise, there are other theorems also, but we don't need to study this time. Okay. Theorem number 3, the last theorem of this chapter. This is called alternate. This is R. Okay, alternate segment theorem. Okay, the last theorem is called alternate segment theorem. It states that the angle between a tangent and a chord through the point of contact is equal to the angle in the alternate segment. Okay, so the theorem states that the angle between the tangent and the chord through the point of contact is equal to the angle in the alternate segment. Let us draw a circle. Okay, let us take a point on the circumference P. Let us draw a tangent through the point P. Now this is a tangent. Okay, now let us draw a chord through the point P. Suppose this is Q. So PQ is a chord and this line is a tangent. Let us name the line A. B. AB is a tangent touching the circle at point P. Now, as per this theorem, the angle between the tangent and the chord through the point of contact. Okay, let us take this angle. This angle means angle QPA. This angle will be equal to angle in the alternate segment, means the other segment. Now see, segment means the region bounded by a chord and an arc. Okay, see this circle. PQ is a chord. This is one segment. This is another segment. Okay, this region is called minor segment because it is smaller in size, and this segment is called major segment. Clearly, the angle between the tangent and the chord is in the minor segment. So it will be equal to angle in the alternate segment subtended by the same chord. So this is the major segment. Okay, this region, major arc gives you major segment, minor arc gives you minor segment. Very simple. Okay, since the angle is in the minor segment, therefore we will take angle in the major segment. Okay, so let us take a point anywhere on the circumference of this circle, but on the major arc. On the major arc, not here. Okay, leave this part. Take any point on the major arc. Suppose I will take this point as R. Let us join RQ and RP. Now this angle will be equal to this angle. So angle between a tangent and a chord in one segment is equal to angle in the alternate segment, the other segment. Similarly, this angle, okay, angle between tangent and the chord PR in this segment is equal to angle in this segment. So this angle. Okay. So this is called alternate segment theorem. Clear? So I hope you have understood the concepts regarding tangent, the corollary, the different theorems. Okay, this is a very small chapter because it has been reduced due to this pandemic. Other theorems are not there, so I am not going to teach. So these are the theorems, 3 theorems. Okay, all these theorems and corollaries are very important. You have to remember. Okay, so thank you for watching.